In the following problem, we are going to be determining which, in a series of alcohols, which of these can be prepared by the reaction of the Grignard reagent with an ester. So which of these can be prepared by that, Grignard and an ester? So I'm going to draw a different structure, and then we're going to be analyzing which ones we can make using that reaction. So this is what I'm doing. We're reacting Grignard with an ester, and we're going to determine which of the following molecules can be made using that reaction. So, all right, so here I have several alcohols. And I'm going to get another here. That's one alcohol. That's 2-butanol. Now I have OH. That will be 2-methyl 2-pentanol. Let me write it here. It's always a good idea. So if you're giving a problem with names, you need to draw the structure first. So this is 1,2-methyl 2-pentanol. This one is 2-butanol. Okay, I'm going to draw another, and that is 1, 2, 3, 4, so that's 1-butanol. I have another compound here, let's see. One, 2, 3. So that will be 3-phenol, 2-propanol. And I have a couple more alcohols here. So this one longer chain. So 1, 2, 3, 4, 5, 6. So it's a hexanol. It's a 3-hexanol. That is 3-methyl. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7. Heptanol. Heptanol. Okay. In carbon 3, you have the alcohol in the middle, all right? And yet I have another structure, which is the following. Here you have OH, metal, and okay. And now let's analyze which of these can be prepared by the reaction of a Grignard with an ester. For that, let's remember what that reaction is. And here we go. I'm going to just draw a general ester. So let's say that I have this structure. I'm going to make OR here. When you're reacting with a Grignard, and let's say that I have just I don't want to use so many R's, so let's do methyl magnesium bromide, which we know we prepare from the halide and the magnesium in dry ether. All right, so now here you're going to say this is polarized this way. You have nucleophilic attack. You will form an intermediate that will have this negative charge. And now you have a metal. I'm just drawing that line, right? And so here you will have now reformed the carbonyl, and that exits, and that forms a ketone. And that ketone, if we have an excess, here we will have an excess of metal magnesium bromide. We will have a second nucleophilic attack. The second nucleophilic attack is this here. Now attacking over the ketone. And here you will have metal, metal, O negative. That's R. But notice what we see, excess of this reagent, because you're doing two attacks. First you attack on the ester, reform the carbonyl from these tetrahedral intermediate. Now you have a ketone ester. And so because we have an excess, we will have another attack. And that's a product. These alkoxide, of course, we will protonate and we will form a tertiary alcohol. So knowing this, let's analyze the structure that we have. We need to have, to be able to make it from an ester, you're forming always a tertiary alcohol, one thing. And from the ester. And the other thing that is important to note is that you're having an excess of this reagent, and these two groups are the same, which are coming from the Grignard. So let's analyze the structures then. What we have here is a secondary alcohol. So that's not what we form here, because remember you're forming a ketone, and ketones reacting with Grignard will give you a tertiary alcohol. So not that. I cannot make that. So which, let's say, which of these alcohols can be made using this reaction, right? Grignard with ester. So that is not possible because, again, it's a secondary alcohol. Now, here in this structure, you have, notice, metal, metal. So actually, that one you can form is a tertiary alcohol, and that you can make starting from, if you have the ester would be, notice, 1, 2, 3, 4 carbons. So you need to start with something like that. And metal magnesium bromide. So that at the end you have these two attacks. So that is to make this. Now, one butanol, well, that is a primary alcohol. And as we can see, the reaction forms a tertiary alcohol. So that is a yes, this is a yes, this is no. I cannot make it that way. Here, this alcohol is secondary. Again, we don't form. From esters, we cannot make secondary alcohols. This substrate here, that is, it is tertiary, but what do we see here? That the three R groups are different. So I cannot be using the same Grignard twice because I need to have the two R groups the same. And here I have ethyl, methyl, and 1, 2, 3, 4, and butyl. So doesn't work. Again, because the first condition is that it was a tertiary alcohol, and the second is that you have two groups the same coming from the excess Grignard. Not the case here, so here I cannot make it that way. Not. This one here, however, yes, you can do this. And why is that? Because notice that this group, this is tertiary. That alcohol is tertiary, and this group is, say, a benzyl, and that's benzyl. So, to make that, I should be starting from 1, 2 carbons. So, an ester with 2 carbons. Right, this 2. There's 2 carbons. And I need to make it react with benzyl bromide, benzyl magnesium bromide, not phenol, but benzyl. So the Grignard, in this case, will be all of these. So I need an excess of the benzyl magnesium bromide. That is your reagent, so that you attach all of that. I'm abbreviating this as pH, benzyl magnesium bromide. So here's the thing. So we have determined that to make a tertiary alcohol, to make an alcohol from an ester, to be able to make any of these alcohols, if you're using an ester, you're always getting a tertiary alcohol. And second thing is that two of the R groups need to be the same, because this is a reaction that you do with an excess of one Grignard reagent.